Okay, so welcome back. So we will look at the fifth module for this fifth lecture, actually, for this module one, and which is focused on design for sustainability, economic, environmental, and social indicators. So let's share my screen. Uh, you should be able to see the slides now, and then put it on a slideshow. So there we go. So this video is focused on design for sustainability, economic, environmental, and social indicators, and examples of use of a LCA tool. So the PDF is already available. You can look at the PDF. So we'll go a little bit. The videos are a kind of summary of this PDF. And then, of course, well, there are a lot of other material has been provided to you as per the webinar and the other intensive courses which is out there. So when we say designed for sustainability, as we know, the sustainability has three pillars. So economic, environment, and social. And you're looking at designing, but many times when you hear the term sustainable design, it could be designing objects that are made from the renewable sources, designing for need and function, designing object that has a positive long-term social impact, understanding the whole earth impact that a product may have through its entire life cycle. So why it is good? Why we talk about sustainable development? Actually, we are living in an ever-changing world. We have to take care of our planet. And I keep on saying that if you look at the age of the planet, it's around 5.6 billion years old. And the humans, as we have existed on this planet for only around 200,000 years. So we have existed, if you take the time scale of 4.6 billion years and put it in a 24-hour scale, what you see is that actually we have stayed only for 4 seconds. We have only existed on this planet for 4 seconds, and in those 4 seconds, we have created so much of mess. We have created so much of carbon emissions and all that. So we have to reduce this carbon waste to promote the growth in our planet's ozone layer. Reduce the carbon emissions means that our planet is more likely to continue to exist in its current form, or even we have to make it actually a better form. So we have to change our attitude to what we buy, how we design, using material that are from resources that won't run out and that will benefit the planet. So these are developing the design ideas. So those are how to design the product better. So those are the ones reduce, reuse, recycle that you hear all the time. The 3 R's, now there are 4, 5, 6, 7 R's. A lot of R's are getting into important, but reduce is the most important. How to reduce the stuff, understanding of the life cycle of the product, the entire value chain, looking how we have a holistic approach. So in terms of the decision making, looking at the material properties, how much is the embodied energy? The embodied energy is the energy that any material uses to be made. Glass has a high embodied energy. It uses a lot of energy to be made, as opposed to wood, which is a low embedded energy. So when using a material, think about where it comes from, how it got into the form in the front of you. Understand the material properties. Develop your own design. So you have to come up with your design in terms of what is the need, what is the waste, what is the recycle, what is the life cycle of that. Then you come up with try to be as sustainable as possible. So when we say sustainable, what does that mean? It means the development that meets the need of the present without compromising the ability of future generation to meet their own needs, as per the Brundtland report in 1987. So it is why it is that much important now, because after industrial revolution, we have been extracting a lot of materials. We're making a variety of products, consuming a huge amount of energy and producing a lot of waste and huge amount, so like several landfill sites, dump sites around the world. That is unsustainable system. So we are putting so much of toxic stuff in the waste, in air, water, and soil. We say it would be a huge concern for future generation. We are seeing the impact already, large amount of waste, so and a lot of regulations and other things. So we need to kind of do better. We need to have a system where we look at the economics, environmental, and social together and come up with a sustainable circular economy kind of system. So it has to be a green shift, and things has to be a greener. So that was sustainability was part of the Agenda 21 of the summit of 1992. representatives stood for 90% of the Earth's population, single largest gathering of heads of the state in the history of international diplomacy. That was in 1992. So the quality of life on Earth, they looked at that, efficient use of Earth's material, protection of our global commons, management of human settlements, chemicals and management of waste, sustainable economic growth. So how we get there from here, we have to start looking at negative impact, reducing environmental impact, ultimately going to the no net impact and going towards more even positive impact. So in traditional engineering, we are trying to solve problems. Engineering, we basically look at maximizing the function, minimizing the cost. And when we look at the cost, we just look at the kind of a called like an economic cost. We don't look at the environmental cost. So we have to have a shift in the engineering mindset. We have to look at the economic cost, we have to look at the environmental cost. We also have to look at the social benefit, environmental benefit associated with that. Social, economic, environmental, when all the things come together, then you have the sustainable. So design towards sustainable, and that must change, that we have to change the way people think about sustainability. We have to stop doing business as usual, find ways to be closer to nature, lessen environmental impact, save energy resource, build on the small success, like do some pilot plants, spread the word when you market your capability to both existing and new clients. So you have to, what professionals do, they come up with the design to reduce material energy use renewable energy sources, maximize lifespan of the structures or the product, reduce construction waste. And if you're talking about stuff in construction, reduce, eliminate hazardous waste, minimize maintenance, and all that. Most importantly, design it either reduce or eliminate greenhouse gas emissions, indoor air pollution, ski pollutions, and making sure that it's economically it does make sense in terms of all. And you should take into consideration all costs, including energy cost, water cost, sewerage management cost, chemical material management costs, maintenance and operation, lifespan, replacement cost, everything should be taken into consideration. So, and then we have to also look at, for example, what can, in some of the projects, what professionals can do, say in sewage treatment plant, digester gas can be used for energy, heat exchanger can be used on sewage effluent, heat circulation from transformers, blowers, irrigation using the plant effluent, urban development, again, redevelopment of brownfield sites, previous pervious pavement, residential systems, construction wetland, similarly transportation, public transit emphasis, pedestrian bicycle friendly, animal bird crossing culverts, reuse of the material. Similarly, architectural and building system, try to go for more sunlight, more and wind energy, look at having a proper ventilation, reuse of a structure using natural ventilation, low flow toilets and urinals, solar system, automatic light control, and you also what professionals can do in terms of enhancing their skills, look at, keep yourself up to date, go to the conferences, go to the workshops and learn from each other. That's very, very important. So there are research, government funding and incentive program is there, the green jobs and all those. LEED certification is available, LEED certification process. I'll not go into the detail of that. There is again, its bottom line, it stays the same, that you want to have a better product, better solution, and then invest lesser environmental footprint. So in terms of the green, look at the different certifications of that. And documentation certifications are very, very important. Some of them, sometimes they are not that enjoyable to do that, but still you need to do it. So, and then in terms of getting things done, as I keep on saying, in fact, on all the platforms, that we need to have a collaborative, holistic approach. This problem is one person cannot really solve the entire problem. You need to get people from different different domain to really solve the problem. Okay, so that's very, very important. So sustainable development, we talked about that, sustainability checklist and all that. So to ponder, if we not do it, then who will do it? We need to, and if not this way, then how will do? If not now, then when? So there is a lot of push on engineering design for sustainability, where engineers will play a major role in terms of having a lesser carbon footprint. Engineers create designs. So field of transportation provides, for example, multiple layer of systems. Engineers create design. Engineer design engines, improvement of design of fossil fuel powered vehicle, and all that, size, power, fuel efficiency of the engine, emissions reduction, use of material and fuel by automobile and embedded in complex flow, developing systems to recycle, make up the automobile at the end of its useful life, use of alternative power source, design of cities. So there are a lot of engineering design for sustainability. People are looking at a lot of these things in there. There are some sustainable design challenges coming up from time to time as well. So as you can see in terms of the sustainable stuff, a lot of work needs to be done, and then it's a lot of work is actually happening right now. In terms of sustainable engineering design principle, essentially coming from the Brundtland report, then Hanover principles, that human system must design to coexist with natural system. Then there was a materials declaration in 2002 in terms of energy efficiency, optimization, exploration of raw material, looking at environmentally benign design material manufacturing over stages of lifetime. So those are some of the stuff as part of the declaration. And there are some principles in terms of engineering processes, improve natural ecosystem, life cycle thinking. So those are there. So there are some Sanderstein sustainable design principles are there to prevent waste, create engineering solution. There are green engineering principles are there as well. So you can look them up. You can read through all those. I'm not going to read them. So there are all these. The bottom line again is to look at have a lesser environmental footprint, better for the economy. So economic performance also we have to kind of look at, and environmental and societal benefits, that is also important. And then you do environmental accounting in terms of the internal cost, external cost, what is the environmental fees and all that. And then you have a tip according to you look at typical like a management accounting system. You kind of look your material, labor, and other things associated with that. That you need to look at as well. Then environment and social expenses. So as you can see, it's like you kind of a variety of stuff can be done in terms of in terms of plastic waste in plastic waste management. So in terms of this estimates of in terms of this values, the numbers, the budgets that is out there, I would request them to kind of submit like this can be submitted in a not as part of a regular like when you somebody is submitting this stuff, we can have a separate doctor submission for those estimates as well. Okay, so these are some of the tables which kind of talks about pollution control expenditure, how much pollution control was there. And here they talk about estimate control cost for greenhouse gases from a EGU or power plant as percentage of sales. So you have this data is available, and then estimate control cost for greenhouse gases when they are using this coal, electricity generated per ton of carbon. So 1 ton of coal, and this much we can calculate it. And then you compare it with the other things in there and evaluating the environmental cost, total cost, tier one, tier two, tier three, tier four. Do some cost benefit analysis, look at the capital equipment, material cost, environmental cost, liability cost, and then total environmental performance indicators. We can have a look at those things as well. So I think we are kind of coming towards the end of this particular video. This is like your week 4. As you can see, I'm just scrolling down while I'm talking because almost all the things were covered by Ayushi in the previous class as well. So thank you very much for this stuff. So I think we can stop this over here. Some math examples are there, which kind of these are most of this stuff is self-explanatory. I'm not going to spend too much time on it. So thank you again for this, and then we will see you in the next video.